During a hockey tryout, all the players met on the ice after the last practice and shook hands. There were a total of 300 handshakes. Write an equation involving combinations whose solution would determine the number of players on the ice. Well, we don't know how many players there were grand total, but a handshake is when you select two people at once. So it would have to be, we had a bunch of people, we paired them up two at a time, and we got 300 different ways that they could be paired up. A handshake, by the way, is a combination because the order in which it happens does not matter. Jason shakes hands with Jennifer is identical to Jennifer shakes hands with Jason. A handshake is a two-way street. Something like Jennifer throws a snowball at Jason is not a two-way street. For that, we'd have to use permutations because her throwing at him and him throwing back at her are different actions. They don't necessarily happen together. But a handshake, it doesn't really matter whose name you say first. It's a handshake either way. So there's our equation. How do you solve something like this? Well, one way is to throw numbers at it until it cracks. NC2, let's try, I don't know, how many players show up at a hockey tryout? There's like 20 on a team typically. Let's say they had 40 players, and we'll see what happens if there's 40 C2, how many handshakes would we get? Too many. 40 is way too many players. Let's cut it down to 30 and see how much of a difference that makes. 30 is still too high. How about 20? Oop. Math, left, 3, 2. 20 is not enough. So the number of, we had 435 handshakes, 190 handshakes, 300 is right in the middle, so we have somewhere between 20 and 30 players. Let's try 25 players. Bingo. With a little bit of luck, we found it in only 4 iterations. But Guess and Check says there are 25 players. Now, with factorials, how does this work? You have a definition for the combination operator, NCR, which says it's the number on the left, factorial, divided by the left number minus the right number, factorial, and also divided by the right number, factorial. This can help us. This plus our factorial skills, which we haven't used in a little while, can allow us to solve this kind of equation. For us, it's going to look like, well, our left number actually is n, and our right number is 2, so we get this. N factorial over n minus 2 factorial, and also over 2 factorial equals 300. First thing, 2 factorial is simply 2. You can take the exclamation mark without making any difference. Multiply both sides by 2, and that 2 cancels out, and we get to here. N factorial over n minus 2 factorial equals 600. That's a small improvement. Now, you remember how we would explode these factorials and write them as big lists of numbers and try to get them to cancel? N factorial is 1 times 2 times times n minus 2 and n minus 1 and n. N minus 2 factorial is 1 times 2 times up to n minus 2, and that's it. And remember, all this equals 600. So once they're all written out in list form, you can cancel everything up to n minus 2. And all you're left with is n minus 1 times n equals 600. Multiply this out, and you get n squared minus n equals 600. Take the 600 over to the left, and you get a quadratic. N squared minus n minus 600 equals 0. Now, to factor that, you need two numbers that add up to -1 and multiply to minus 600, and obviously those numbers are 25 and 24. Everyone learns to factor 600 on their grandmother's knee, I'm sure. And so the two solutions for this are n is 25 or n is negative 24. Just like you can't have negatives in a factorial, you can't have negatives in a combination. You can't say, here are minus 24 things, select two of them. So that negative answer is extraneous, away it goes. And here's the 25 that we got by guess and check. So yes, guess and check was cool here because the numbers weren't all that big. We were able to guess our way down to the correct answer. But if this equation were a little bit more complex, or if the numbers were bigger so that we just couldn't do enough guessing in time, the factorials are the way that you can solve these things. Just remember, you can turn a combination or a permutation into a factorial expression like this, and then it's all about canceling the factorials against each other.